Good afternoon, dear visitors. Let me present you the main result of the study on the topic simulator of the computer networks and basic network protocols. We live in a country of information and communication systems and technologies where it is impossible to imagine any organization without modern computing technology. Computer networks are characterized by the complexity of the topology, so the questions often arise of preliminary modeling of computer networks. Throughout modeling the optimal topology of the future network, the necessary network equipment, as well as the possibility of future development is determined. In addition, modeling computer networks avoid the costs that result from actually building and network in the future. Also, for the correct interaction of computers operating in networks of different structures and using different software, it is necessary to have certain standards. These standards currently exist in quite a large number. For developing countries, this highlights the challenge for training and educational institutions as a demand for IT professionals continues to grow. Understanding how computer networks are designed, how they function, and how they can be managed is a necessary skill that IT professional must acquire. Students studying in the field, while information technologists have a list of compulsory disciplines for study. One of these disciplines is computer networks, as a result of which students should be able to explain the basics of the function of computer networks. To achieve this learning goal, students will have to spend many hours on the hands-on design, configuration, and implementation of computer networks. Efficiency in this direction is achieved only when there is enough quality equipment to allow the individual practice of customizing software. Uh, in our study, we describe analysis of analogs of software products. Also, Cisco Packet Trackers is a network simulator that can be used by students as well as teacher and network administration. Packet trackers has two workplace, logical and physical. The logical workplace allows users to build a logical network topology by placing, connecting, and clustering virtual network device. The physical workspace provides a graphical physical dimensions of the logical network, giving a sense of the scale and the placement of how network devices such as routers, switches, and hosts would look in a real environment. Graphical network simulator is used by hundreds and of thousands of networks engineers around the world to emulate, configure, test, and uh, troubleshoot virtual and real networks. This was confirmed by the result of the crowdfunding campaign, during which the GNS3 developer quickly collected quite a substantial amount for the development and software package. Our study described the properties of computer networks and physical device, but let's view in detail on developing a computer network simulation. Simulator of computer and basic network protocols must provide the same capabilities, namely the design of computer network and the study of their work. The computer network simulator should provide the ability to add device to the network. Each device can have network cards containing ports for different communication channels. Each device has parameters such as name, IP address, and others. Devices might be connected via communication channels. Device can communicate with each other via communication channel. In a computer network simulator, the functionality should be implemented that allow you to track the process of communication between devices. The main function of the computer network simulator is to enable users to connect to each other networks. The user can open access to the network with the ability to view or edit in real time. After analyzing the requirement of users, we highlight the following use case. First, create a new network project. Second, selection and creation network device. Third, select and create connections between device. Fourth, set up an IP address for the created devices. Fifth, viewing the network log of device. Six, create and send traffic between devices. 7, ability to open access to your project, and 8, opportunity to join another project. Let's define the functional requirement for the simulator. First, building a computer network. The system must have a set of program device and connection with which you can create and expand a computer network. And second, the work of several people on the project. The user has the opportunity to open access on this project. The analysis of functional requirement made it possible to single out the following entity through which we implement the software product. The view model being the model and the view throughout a data binding mechanism if parameters values change in the model. When the model implements them, it notify property change interface. The display date in the view automatically change. Also, the model and views are not specifically connected. The view model also contains the logic for getting date from the model, which is then passed to the view. The view model also defines the logic for updating the date in the model. Since view element that is a visual component such as button do not use events, the view interacts with the view model using commands. For example, the user wants to save the date entered in a text file. It presses the button and thereby sends a command to the view model. And the view model already receives the transferred state and updates the model accordingly. In the diagram, you can see 4 classes of windows and 2 classes of graphics elements. The main window class is responsible for displaying the main user interaction element. The main window class also displays device and connections added by the user. The log windows class is responsible for displaying the device log, which you can trace that is happened on the device. The configuration window class is responsible for displaying device information and editing its IP address. The traffic windows class is responsible for creating and sending artificial traffic from one device to another. The open system user control and physical media user control classes are responsible for the graphical displays of device and connections as well as user interaction on the main window. The diagram also shows 4 classes of view models which contain the user interaction logic and the 2 models which store information about device. In the diagram, you can see the classes for communicating and an application with another application of this type. The classes are implemented using the VCF framework. They are designed and implemented in such a way that the application can work in client-server mode. The sharing service class contains the functionalities responsible for running the application in server mode. The sharing service client class contains the functionality responsible for running the application in client mode. The sharing service callback class contains functionality that helps the server communicate with the client. In the diagram, classes representing network device are visible: base open system, computer, router, and switch. The base open system class is the parent of the computer, router, and switch classes. It includes the functionality and database of to all network devices. The computer, router, and switch classes override the functionality implemented in the base class. The diagram shows the base network interface controller and network interface classes for working with network cards and network interface. These classes implemented functionality for sending, receiving, and processing data. The diagram also shows the physical media, cable, and connector classes, which implement functionality for connecting network device and transferring data. The internet type to frame class represented an Ethernet frame used for communication between devices. The upper PDU class represent an RP packet that, when passed down to the layer, is encapsulated in the Internet frame. After launching the program of the computer network simulator, user can create a new project, add device to it, and a connection between devices. Add traffic from one device to another, open access to the project, or connect to another project. Also, after creating a device, when you right-click on the device, an accessibility list appears with a choice. Open the setting windows or the log windows of this device. When choosing the option to create a new project, the command is created that clears all of the files that were previously filed in and insert them with new values for the new project. The add device to project option create a command that inserts a new device and adds it to the collection of created devices. This collection is associated with the view of the main window. That is, when updating, adding or deleting the collection graphics elements with a pair of the main window which you can interact. Adding connection works in a similar way to other device. A project must have at least two devices to be able to connect them. When you select the traffic creation options, a new window opens in which you can select which device the traffic will be sent from, which device this traffic should come to, and which protocol packet should be sent. After filling in all the fields, the users present the send button, which generates a command to start the process send traffic. One of the main processes of a computer network simulator is sending data from one device to another, provided that they are connected. The process of sending data begins in the base open system class in the send data method. This method takes an instance of the Internet time to frame class as the parameters and knowing what from which MAC address the data should be sent, select the network interface with the corresponding MAC address and call the send method of this interface. Having received a frame, the network card decapsulate it and paste it to the handle value method of the date link layer service class, which in turn process the packet using the R protocol service helper service as shown in the slide. Well, let me describe our simulator. The K class that host and communicate with the application is service host. It is part of the system service model names as. So, to create a network project in which you can build a network, you need to click the item file, create project. Once the project is created, the user can add the device by clicking device and selecting one of the options, computer, route, or switch. After creating at least two devices, the user can connect them using connections physical media. By clicking on the item physical media, the user must click on the two devices that he wants to connect. To connect traffic, you need to open the traffic create windows using traffic and data. In the window that opened, you need to select the device from which the data will be sent, the device to which they will have to reach, and what type of protocol will be encapsulated. To communicate with other applications, the user can open access to the project using sharing open access, so that other users can join his project to join someone else's project. This user must select sharing connect to a shared project. In addition to the menu, the user can interact with devices in the main window. The user can call the context menu of a device by right-clicking on it. In the context menu, there are two options for selecting configuration, which opens the device setting windows, and log, which opens the device network windows. By opening the device installation window, the user can see the static settings of the device and its network interfaces. The user can edit the IP address of the network interface. The device network log window that opens shows the actions that took place in the device context. After creating the devices, connecting them to the network and configuring them so that they have the same IP addresses. IP glitration packets are sent with the help of which they learn about the conflict of the IP address. On the slide shows an application action in a server. A project was created in the application and two computers were added which were connected to the network. On slide, you can see an application that acts as a client and has been attached to the application. After connecting to the server application, the client application saved the project date and reproduced this project in the network building space. Also, the client application, having received the date, can trace and action that took place in server application using. The analysis of software analogs made it possible to present their advantages and disadvantages. The given theoretical information about the network properties of devices and protocol made it possible to formulate their equipment that the designed simulator must be. Designed and developed the structure of the program code and the main architecture of the system. Classes for interaction with the user and classes for the operation of the application for communication between applications are described. The methodology for using the created application is described in our article, and we think that the design software meets the requirement and is satisfactory fast without taking up large resource of the computer on which it is running. We see the expansion of the functionality of the simulator as a prospect for future research. Thank you for your attention.